Today we shall learn how to find the length of a line segment. Let us start by revising how to find the coordinates of the following points. Remember to read the coordinates from the x-axis, then the y-axis. Yes, this point is 1, 2. Now what is the coordinate of this point here? Yes, it is -3, 1.5. What about this point here? Yes, it is -4, -2. What about this point on the x-axis? Is it 4, 0 or 0, 4? Yes, we will always read the x-axis first, and hence it is 4, 0. And finally, what is this coordinate here? Yes, it is 0, -2. Next, we shall recap on how to find the length of the following horizontal and vertical line. What is the length of these line segments here? Yes, it is 3 units. Now, how do we get 3 units? Besides counting, we can also find the length of this line by using 4 minus 1. And hence we have 3 units. What about the length of this line? Remember, we can use the bigger number to minus the smaller number. And hence we will have 2 minus -1.5. And the answer is 3.5 units. Now what is the length of this vertical line here? Yes, it is 1 minus -4, and we have 5 units. Now what happens if the line is a diagonal line segment? How do we find the length of this diagonal line? Very good, we shall use Pythagoras Theorem. First, we need to find the length of this vertical line and the length of this horizontal line. And the length of this line is 3 minus 1, which is 2. The length of this horizontal line is 4 minus 1, which is 3. Do you remember the Pythagoras Theorem's formula? Yes, it is c squared equals to a squared plus b squared. And hence, to find the length here, we can use c equals to square root of 2 squared plus 3 squared. By pressing the calculator, we will have 3.61 units, rounding off to 3 significant figures. Now let us try to find the length of these other line segments here. Now what is the length of this vertical line here? Remember to always use the bigger number minus the smaller number. And hence we have 3 minus -1, which is 4 units. What about the length of this horizontal line? Yes, it is 2 minus -3, which is equals to 5 units. Again, applying the Pythagoras Theorem, we will have c equals to square root of 4 squared plus 5 squared. And we will have 6.40 units, rounding off to 3 significant figures. Now, the coordinates of these two endpoints here are 2, 3, and -3, -1. And hence the coordinates of this point here is 2, -1. Now we shall derive the formula for finding the length of a line segment given two coordinates. Now let's call the two endpoints on the line segments to be x1, y1, and x2, y2. And hence the coordinates of this point here is x1, y2. Next, the length of this vertical line is given by y1 minus y2. And the length of this horizontal line is given by x1 minus x2. Using Pythagoras Theorem, we can find the length of these line segments given the coordinates of two endpoints. Hence, the distance of these line segments is square root of y1 minus y2 square, which is your a square, plus x1 minus x2 square, which is your b square. This is the formula that we can use to find the distance of the line segments given the two coordinates of its endpoints. We can also rewrite it as square root of x1 minus x2 square plus y1 minus y2 square. x1 comes from the x-coordinates of the first point, while x2 comes from the x-coordinates of the other points, while y1 comes from the y-coordinates of the first point, and y2 come from the y coordinates of the other point. You have to memorize this by the end of this lesson. Now, this formula is very similar to the Pythagoras Theorem, which is square root of a squared plus b squared. And hence, all you need to do is to remember to substitute a by x1 minus x2 and b by y1 minus y2. I'm sure you can remember the formula in no time. Let's continue by looking at an example. A and B are points on the coordinate plane. The coordinates plane consists of the x-axis and the y-axis. And we're asked to find the distance of AB. In order to do so, we shall apply the formula square root of x1 minus x2 squared plus y1 minus y2 squared. Now, the x1 and x2 will come from the x coordinates here, and the values of y1 and y2 will come from the y coordinates here. By substituting all these values in, we will have square root of 9 minus negative 7 squared plus negative 5 minus 12 squared. Now, it does not matter which x or which y you write first, because after squaring it, you will get the same answer. Simplifying, we will have square root of 16 squared plus negative 17 squared, which will in turn give us square root of 545. Pressing the calculator and rounding off to 3 significant figures, we will get 23.3 units. Now, that's all for this part of the lesson. Now, do remember to memorize this formula to find the distance of a line segment given two coordinates, which are the endpoints. Well, that's all for this lesson.